This is Mr. Martin. These are video notes for Pre-Calc Honors Section 9.3. We're going to be talking about hyperbolas. So as always, let's start out with a definition. So for a hyperbola, it's the set of all points in a plane where the difference of their distances from two fixed points, and again these are called foci just like they were for ellipses, except it was the sum of their distances, is constant. So with an ellipse we had these two distances and we added them up and we always got the same value. For a hyperbola, we're going to subtract these two distances and always get the same value. Alright, so you can see here in this picture, here's D1, here's D2. I'm going to subtract those and I'm always going to get the same value. Alright, so let's take a look at the parts here before we look at the standard equations. We've got our vertex in the middle. Okay, we're going to have vertices. So I have a vertex here and a vertex here. Notice the distance to the vertices is a distance A, and that's the same as it was for an ellipse. This is going to be our transverse axis is going to be horizontal. That's what we call our major axis, is transverse axis. And then again I have a B distance as well. Notice that dotted rectangle in there. So starting at our center, we go A units along what we would like to think of as our major axis, and B units along our, you can think of it as a minor axis. And then our foci again is going to be C units away from the center. Notice how the foci are inside the curve just like they are for an ellipse, and also the focus is inside a parabola. And then we're going to have our major axis, which we call the transverse axis, which I mentioned. And then this other axis, which is, you can think about it like our minor axis, is called our conjugate axis. Okay, and this vocabulary is important because if I give you information that's referring to either the transverse axis or the conjugate axis, you'll need to know what those are. Okay, so these are the parts. Again, we could turn it horizontally like this, or we can turn it up and down and make it vertical. So our standard equations of the hyperbola, it looks very much like an ellipse, except that we've got this minus in here because we're talking about the difference of the distances being constant. Okay, and again, if you notice another difference here, a squared and b squared are always in the same order for these. So what determines horizontal or vertical transverse axis is which one of our terms x minus h squared or y minus k squared comes first. So if our x minus h squared is first, we've got horizontal. Okay, x is our horizontal axis, so our hyperbola is horizontal. Or if y minus k squared comes first, we know the transverse axis is going to be vertical. It's going to open up and down. And again, notice we have a relationship between a, b, and c. In this case, it actually is the Pythagorean theorem. Okay, so this is again similar to what it was for ellipses, except instead of subtracting a squared minus b squared, we're going to add them. Alright, a couple more diagrams here. Here we have vertical transverse axis with our center at 0, 0. Notice these red dotted lines here. We've got our asymptotes, and we'll talk about those in a bit as well, a little bit more. If we're looking at you know, that box that we had in the other picture, the box would look something like this. Okay, and this is going to be important for you to know how to draw when we're sketching these hyperbola. That should go right through the corner there. That's a little bit off. That should go through the corner there. Just trying to sketch these in as accurately as I can. Alright, and then our box over here goes something like this. And this would be 0b, and this would be 0, negative b. Again, we're centered at the origin. And then over here I would have b comma 0, and over here I would have negative b comma 0. Alright, and then we would also have our foci, so if we wanted to draw those in, I could draw those in. We'll just kind of guesstimate where those need to be. So this would be C0. This point here would be negative C comma 0. And again, if we wanted to just sketch them in over here, that would be 0 comma C. And this would be 0 comma negative C. So again, if you have any questions about the parts, it's very important that you ask me those questions. Alright, so let's move on to an example. We want to find the standard form of the equation of a hyperbola with foci at 0, 0, and 8, 0, and vertices at 3, 0, and 5, 0. So again, I always like to draw it out. So I've got a focus at 0, 0, and another one at 8, 0. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Alright, so I know my center is going to be directly in between there, so it's got to be 4 units from each. So my center, let's go ahead and write that down, is going to be at 0, 4. It's got to be right in between. And I've got vertices at 3, 0. Let's put those in a different color. 3, 0, and 5, 0. Alright, so if we want to just kind of sketch this in, let's find a couple more things first. So the distance from the center to the vertices is going to be my A distance. So A is going to be 1. Okay, that's distance from center to vertices. Alright, and C is going to be the distance from the center to each of the focus points. So that's going to be 4. C is going to be 4. That's distance from center to foci. And from there I know C squared is equal to A squared plus B squared. So I've got 16 minus 1 is equal to B squared, which means that B is going to be the square root of 15. And so since B is the square root of 15, that's about 3.9. So if I go up 1, 2, 3, 4, about 4, just a smidge below. And then we'll go down 1, 2, 3, 4, just a smidge below there. So now I've got my vertices. That's my A distance. So from vertex to vertex is 2A, and then from foci, focus to focus, that's 2C. And what I want to do is I want to draw in a rectangle here. So once I have this rectangle in, I can draw in my asymptotes because they have to go through the opposite vertices of that rectangle. So these are my asymptotes. We always make those dotted. And then my parabola, I can sketch that in. I'm going to kind of follow the asymptotes up and down on the right, and then up and down on the left. So the blue now is the sketch of my hyperbola. Alright, and then I want to find the equation now. So I know it's going to, since it's horizontal, I'm going to have my x minus 8 squared first. So it's going to be x squared because it's x minus Let's see, center, this should be, sorry about that, you guys probably noticed that, that should be 4, 0, not 0, 4. So we've got x minus 8, so that's x minus 4 squared over a squared. So a was 1, so that's 1 minus, and then y minus 0, so that's just y squared over b squared. So b squared is going to be 15 is equal to 1. So there's the standard form, and that's all we need. Alright, so let's talk about asymptotes in the next video. So you can go ahead and stop this one. If you had any questions, make sure you ask, and we will see you in the next video.